Hello everyone, welcome to today's webinar, the Analytics Wave Series Part 3, Prescriptive Analytics. I am Megan Souza, Marketing Manager here with Done Solutions Group. And before we get started, I would like to go over a few items. The session will be recorded and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at donesolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them and we will address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to cover it, we do promise to follow up with you with those. So let's take a look at today's agenda. I will begin by doing introductions to Done Solutions Group. From there, we'll turn it over to today's presenter, Jose Hernandez, who is our Analytics Practice Director here at Done Solutions. Jose will discuss setting the stage. He will then go into what prescriptive analytics are, and then what's next. From that point, we will take any questions that you may have. Please keep in mind that you may chat those in the chat box at any time, and we will address them at the end of the presentation. So let's begin. Done Solutions has a long history of delivering innovative business technology solutions to companies. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into three practice areas: application development solutions, feature portals, e-commerce and content managed websites, mobile application development, and custom application development. Our business intelligence solutions feature analytics and BI platforms, as well as data warehouse and data integration. We are authorized SAP and Liferay training providers and offer classroom, virtual, private, and custom options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500 mid-market companies, government agencies, and nonprofits from across all verticals. About 80% of our business is commercial clients and 20% are nonprofits and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking in the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. We've built strong solutions for our customers, which help them better manage their sales operations and inventory predictions, even helping determine where the next hospital should be built. We make it easy for them to get that information using tools that don't require you to be a programmer, so that analysts and line of business managers can easily access the data that they need to better run the business. We offer a global delivery model that gives us the flexibility to build teams that are best suited to our clients' timelines, budgets, and preferences. Projects that utilize offshore resources are always led by someone local and US-based. Thank you for allowing me to introduce you to Done Solutions. I will now hand over the presentation to Jose Hernandez, where he will begin by setting the stage.
So let's go ahead and we'll intro the topic and talk about why we're going to talk about this stuff. The first thing I want to set the stage with is remembering what the purpose and the goal of business intelligence is. So the whole reason we do business intelligence and analytics is to make sure that we get the right information to the right people at the right time. And this is critical and very important because, especially today, it's a very competitive world that we live in, and making sure that we make the right choices in whatever we're doing is very important. It could result in making or losing a lot of money, time, and energy. So why do we want to make sure folks have the right information at the right time? As I mentioned, to make sure that we're making decisions based on data and not gut feel. Yeah, gut feel is cool, but it's much more reassuring to make sure that that gut feel is backed up by some data. The other thing that we do with getting this information into the hands of the lines of business is to make sure that we can support business processes. and present value-added options to our customers. One of the key things that we've done for some of our customers is we make sure that they're selling products at the optimal price. So using analytics, we can make sure that our retail customers are pricing products and services at that right price. And so that's really the reason for why we do all this work with analytics. Ultimately, it's to make sure we're being more effective, generating more revenue, making more profit, providing services in the most optimal way. During that first wave of our presentation, I introduced the business intelligence pyramid. Back in that presentation, I said that, hey, we had the food group pyramid, which I know nobody talks about anymore, but I thought that we should have a business intelligence pyramid, which basically describes and sets up the foundation of how you do BI solutions. And I know the term BI is a little passé. We're now calling it analytics. But I really want to start with how we got here. So when we think about the business intelligence pyramid, at the bottom layer is the infrastructure and IT activities. This is really stuff that's happening in the back room. We'll talk about that a little bit today as well. And it's really the focus of IT. It's all the plumbing. It's all the persistence of data. It's all the making sure that, that everything's humming along. And why do we do that? We do that so that we can ensure that there's a home for our metrics and key performance indicators. This is where the business comes in. And IT doesn't necessarily know what an organization's KPIs are, though I'm a proponent of making sure that everyone in the organization understands key performance indicators. Their job is to make sure that the infrastructure is in place and to enable the business to then store and expose those metrics and key performance indicators. Once we've got that in place, it's very critical then that we start making use of that information, and that's where analytics really come in. So when we think about those exposing that data and combining it with business process, that's where analytics really comes in. And that's the tip of the pyramid and what we're shooting for.
Not from the telephone option or the mic and speakers option.
Testing 1, 2. Turn on your. Go ahead and talk. Hello, testing 1, 2.
Hello, testing.
Tell them to hold on.
Do you think it's called in?
No, it should not be that. Let me see. 1, 2. Testing 1, 2.
Welcome to the webinar. You have entered as an organizer and may now speak to any other organizers or panelists on the line. When you are ready to begin the presentation, press the Start Broadcast button on the GoToWebinar control panel to allow all attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. I am now talking. If somebody could confirm that they could hear me through the chat window, that would be great. On the bright side, you get to not hear the done commercial again at the beginning, but I can certainly start with the presentation side. So I'm not sure what happened. Hello, everyone. Now you can hear me. This is Jose Hernandez. And what I'll do is I'll back up the presentation a few slides and we'll get started. All right, so I'll do the, I'll take a deep breath and we'll get started again. Cool, I see that. Is that older?
Oh.
Okay, very good. Good afternoon or good morning, depending on what time zone you're in. Hello, my name is Jose Hernandez. I'm the Director of Analytics at Dunn Solutions Group. And today's presentation, we're going to talk about prescriptive analytics. We're going to start by setting the stage and reviewing some of the topics that we talked about in the first two presentations that were part of this series, and that's descriptive analytics and predictive analytics. So we will touch upon that a little bit just to kind of set the stage and flow into this. And then we're going to dive into the topic of the day being prescriptive analytics. So all these analytic things that we talk about really fall under the umbrella of business intelligence, and I know that that term is a little old school now, at least people are starting not to use it anymore, but it does encompass and blanket everything that we do in analytics and business intelligence, actually. The whole purpose of BI and analytics is to make sure that we're getting the right information to the right people at the right time, and the reason we want to do that is to have our employees, our frontline workers, make decisions based on fact and not gut feel. While gut feel is pretty cool, it's much better to make sure that that gut feel is backed up by actual data. And so we do these things to support business processes, to add value to our customers, and for a variety of reasons. So some examples might be to make sure that we're selling things at the optimum price. What is the optimum price? Well, that's a good question. The optimum price is really a price point that you get product moving and you're generating as much profit as possible. And so obviously there's a challenge in making sure that you can do that correctly. Also, another example is making sure that you're staffing your services appropriately for the workload. And so these are two examples of things that analytics help you do. In my first presentation on descriptive analytics, I did introduce the business intelligence pyramid. I based this on the old food pyramid that was popular way back in the day, and so I'm dating myself a little bit. And I thought we should have one of those pyramids for BI. And it is a good place to start introducing, what are all the layers and things that we have to do in business intelligence. And at the bottom of the pyramid is all the infrastructure and foundational things. It's basically where IT lives. And down here, this is where we have our systems, our databases, our ETL processes that are making sure that we can persist the data that we use to drive our business. In the middle, that's kind of where IT meets the business. And here's where we're exposing metrics and performance indicators and key performance indicators via this infrastructure that we've developed. And the ultimate goal is to get to the top of the pyramid, basically the combination of business process and this information, so that if we can drive business process using some of the data that we're exposing as metrics and performance indicators, then we're really reaching our potential in terms of business intelligence and analytics. All right, the one thing I do want to point out is that you don't have to have all the parts of the pyramid done in order to start gaining the benefits of having a BI solution in place, and oftentimes that does occur. It is a process that you can grow, and you can start out by just having some components within the pyramid. Now, if the example I have here, you see that I have some source systems, some ETL and data warehouse in place, and exposing some metrics and key performance indicators. To me, that would be a minimum of what I should have. And I also included in this example analytics, because this whole series is about analytics, so I may as well include that in my sample partially filled pyramid. All right. So when we talk about analytics, we introduced during the first presentation that there are three basic types of analytics, and those are descriptive, predictive, and prescriptive analytics. And it's not one or the other of these things. This really is describing a maturity of moving through these various phases of analytics lives. And so we typically start out with descriptive analytics, and we're going to talk about that in a little bit. And eventually, as we gain confidence and experience in that world, we start moving into the world of predictive analytics. That world of predictive analytics is really where we start talking about data mining and machine learning, and the ability of using algorithms to look at our data and find patterns and potentially do predictions. And then imagine how cool that would be if you kind of knew what was going to happen before it happened, even to some level of probability. That's a very powerful thing to have, and thus people do strive and take advantage of predictive analytics. We'll talk about some examples. And ultimately, once we've got that going and we're confident there, we start talking about prescriptive analytics. And prescriptive analytics, I'm going to oversimplify it, but it really is nothing more than taking the information that you've discovered in predictive analytics and making it part of the business process, whether that's making it part of the business process through human intervention or direct action. That depends on what we're trying to do, but the whole idea is let's take that data, let's take that information that we've mined and modeled, and let's act on it, and let's provide recommendations and so on. So what I'd like to do here is kind of use my favorite analogy that I've been using now for quite a few years, and it's the analogy of the rearview mirror. And so if we think about that descriptive analytics, you know, what is descriptive analytics? It's the ability to sense and respond. In other words, I can look in the rearview mirror and I can go ahead and, given data that I have, I can run reports or I can run some ad hoc queries. I can slice and dice through my data, and I can look and see, hey, let me see what has happened. And that's a very powerful thing, because if I can see what has happened in the past, it certainly can help me with my decision making today and moving forward. But I can do a little bit more and a little better if I can apply data mining and predictive modeling onto this data. So that very same data that lets me look backwards is the data that's going to allow me to go ahead and build some of these algorithms. And the idea is, I've got all this cool historical data. There are patterns living in there. So let me expose those patterns and find it. As a human, I can look at data with one or two variables and kind of see patterns and kind of deduce something from that. But the reality of the real world is that we're not dealing in one and two variables. In fact, we're dealing in dozens, hundreds, or thousands of variables. As a human, I can't analyze that. It's impossible. And so I need math. And math alone isn't going to do it for me. I need math and I need computers because math and computers work tirelessly. And we'll talk about that in a bit. Computers don't complain about working overtime, and they work on weekends, and I can certainly take advantage of that and apply some math to some of the data that I have. And that's the whole idea behind predictive analytics. Now, what if not only could I take a look at the rearview mirror and see what's going on behind me, do some predictive modeling, and look a little bit forward, what if I could also go ahead and use that information to offer up recommendations and act upon those recommendations? That would be the ultimate thing to do, because now I've taken all this data that I've got a hold of, finding nuggets of information, and then putting into my system the ability to automatically act upon it. We call that basically, oh gosh, I have a mental block on the word. That happens to me every now and then. That's what happens when you're north of 50. But it's the ability to operationalize, that's my fun word for the day, to operationalize this data and make it part of the business process, part of the workflow. And that's what we're going to chat about a little bit today. Oh, by the way, before I leave here, that image of that rear view mirror is an actual product that I stumbled upon on the internet, and I've got the presentation will be available, but the URL for that product is down here. It replaces your rear view mirror in your car and actually has GPS navigation built into the rear view mirror. I thought that was a really cool idea. All right, so what I'd like to do now is quickly remind everyone about a particular pattern. It's my data warehouse pattern. The data warehouse architecture, which anyone in BI has been working with for quite some time, talked about some key components. And this particular pattern still holds true today, and it's going to hold true when we talk about analytics as well. And ultimately what I'm talking about are three major components where I have data, my suppliers, and that data might live in a variety of places, my ERP systems, my CRM systems, data streams from social media, for example, or even web server logs. There's all kinds of data waiting to be had. And what we've been doing over the years is taking that data from those systems and moving them into a centralized area where I could go ahead and then combine, massage that data in such a way that I'm gaining more insight into what's going on within my organization by combining all this cool stuff. And then once I've done that, I can go ahead and provide tools to put in front of my business users to either just run reports, do ad hoc analysis, or as we've been mentioning, do some predictive analytics and data mining and so on. And part of the process of moving that data across is the ETL process. The ETL process lets me extract this data, transform the data, and eventually load it into a database for consumption. This pattern is going to play a role in our discussion about prescriptive analytics, and you'll recognize, if we generalize this a little bit, you'll recognize where this happens over and over again. All right, now, there's no magic in a lot of the things that we do, and I do want to point out that there is a lot of effort going on in the back room to make these things possible. Not just traditional data warehousing, but also all these analytics that we're talking about, specifically predictive and prescriptive analytics as well. A chunk of the effort in making all this work is in preparation of the data. So whether it's preparation of the data to store into your data warehouse or preparation of the data to build those predictive models, there's a ton of work that goes on back there. And that's work that isn't seen by the business community and doesn't have to be seen by the business community. It's what the data scientists and the IT folks do, and that's their job. That's what they like to do, to ultimately get the information in the hands of the business users so they can do whatever it is that the business does. But keep in mind, a ton of the work is in preparing that data. All right. With that said, and I tried to do that as quickly as I could to catch up a little bit on time, and I think I'm doing pretty okay here. I want to dive into the meat of our topic today, and that's prescriptive analytics. So when we talk about prescriptive analytics, and excuse me while I take a drink. Thank you. When we talk about predictive analytics, what I want to do is start out by showing you the major difference between this descriptive and predictive stuff and prescriptive. And I found a diagram. I found this diagram in many places now, and I adopted it as part of my presentation. But it talks about, over on the left-hand side, we've got all this information, we've got all this data, and ultimately, all the way over on the right-hand side, we want to turn that into some kind of action. And so these maturity levels of analytics lead us in that direction. So let's talk about descriptive first, that rear view mirror, what has happened. By looking in the rear view mirror and seeing what has happened in the past, we're a little bit smarter about making some kind of a decision. It still does require, if you see in that top row, that gray arrow, it still does require quite a bit of human input to decipher that and figure out what to do, ultimately to make a decision and take some action. Now, what happens when we move into the world of predictive analytics and we start looking a little bit at patterns in the data and trying to predict what the data is telling us, we move a little bit further towards that decision box and have to do a little bit less work as a human in order to do that. So the system has provided us a little more information and made that path between here's some data, make a decision, take some action a little bit shorter. Now, this is where prescriptive makes it a little different. With prescriptive analytics, what we're doing is we're taking even more of that human input out of the equation. In other words, not only am I going to look and see what has happened in the past and take a look and do some prediction, but I'm going to make recommendations to you, and I'm going to put those recommendations in front of you for the human to make that decision. So it's not like I have to decipher and analyze this data now. I'm being given choices. And if we think about that, my cool little rear view mirror with the navigation, imagine that navigation system would notify me that there's more congestion than typical on the path that I'm taking, and it's going to recommend some alternate routes. That's very cool. Some alternate routes, which then I can choose between route A and route B or route C, as many routes as it's offering, and take the action of then following the navigation system. Now, what's the next step beyond that? And that's basically where we add a little more automation. through my prescriptive analytics, not only am I making a recommendation, but I'm going to go ahead and take action. And let's go back to that rear view mirror with the navigation system on it. What if it just simply determined that there was a better route for me to take and just rerouted my path to do that? Didn't even notify me, just went ahead and did it, and I kept following the directions. That's the ultimate in prescriptive analytics, where I go ahead and I look at the historical data, I figure out what's going on, I make a prediction, and I take an action, all within the system, and the human's not really touching that decision. Very powerful stuff when you get it right. Okay, so in order to talk a little bit about this, what I'd like to do is offer up 3 examples of prescriptive analytics. And I chose 2 of these because I'm a user and a customer of 2 of these. And I chose the 3rd one because I think it's one of the coolest things ever. So I haven't actually used it. You can guess the Google Self-Driving Car project. I have not been in a Google Self-Driving Car, but I certainly have a Netflix account, and I certainly fly with American Airlines. And so I want to take these 3 examples and talk about how they're using prescriptive analytics. And we're going to talk about Netflix and recommendations and churn. We're going to talk about American Airlines and price optimization. And finally, we're going to talk a little bit about Google and the self-driving car project. All right. I suspect that many of you out there, if not Netflix, you're using some other streaming movie show service, and been using. Actually, I've been using Netflix since they were DVD only. Yeah, now I'm really dating myself. Back in the mid 2000s, so I was one of the original customers of Netflix. And now that they're doing the streaming stuff, it's very cool. But one of the really neat things that Netflix does, and I'm sure many folks have heard about the contest that they had, having people submit a better recommendation algorithm for them so that they could make better recommendations. That happened a few years ago. One of the really neat things that they do is that they, as you're watching movies, as you're watching shows, they make recommendations of things that you might like. Now, why do they do that? Well, for one thing, it's kind of neat to be offered up new shows and so on that that I might not have known about if it wasn't for some of these recommendations. But that's not really why they're doing it. The reason they're really doing this is they have discovered through data mining that subscribers that fall below a certain number of hours of video watching have a tendency to leave and unsubscribe and basically stop paying. And it turns out, by the way, that that number is about 15 hours a month. So they've determined through data mining that if you're a subscriber and you're watching less than 15 hours a month, they're probably going to lose you. So what do they have to do? They have to make you watch more than 15 hours a month. And how do they do that? By giving you recommendations that'll make you watch more shows. So now you see how these 2 things are tightly coupled. I'm going to make good recommendations to reduce my churn. Very cool stuff. In fact, they're very clever about some of the things that they do. You may have noticed, if you're a Netflix user now, that as you're watching a show, they're even monitoring if you stick around for the trailer of that show, because if you don't, that means you're going to leave and you're not going to keep watching. You're not going to be an active watcher. And what they'll try to do is either take you, during that trailer, take you to the option to go to the very next episode of the show that you're watching, or make some other recommendation of another show. They want to capture you even there to keep you on, to keep you watching. And the whole idea is to keep you above that threshold of hours that makes it likely that you will not leave. Very clever stuff. I'm going to talk a little bit about how that kind of works in an oversimplified general way, not the Netflix secret sauce. All right, I'm going to let this picture sink in for a second. We're going to talk about it and what they do. And so how does a recommendation system work? There's a lot of cool stuff happening to get this to work. But ultimately what we do is we have subscribers, we have people that are customers of this particular service. And using predictive analytics, we try to set these people in groups that they are similar. And so how do we do that? If you think about Netflix, if you think about the data they capture, they know who you are, they ask you questions about male and female, they know what shows you watch, they know all kinds of cool stuff about you. And the reality is that with all this data mining and predictive analytics stuff, the more data we have, the better it is, and we'll talk about that in a bit. So the first thing you do is you take all these subscribers and you group them up into segments. And how do you know how to group them up into segments? You don't. The math does. Using that data and using some algorithms, there are these entities get grouped up in certain ways, in certain groups. Now, you're wondering, well, how do I get that data into some algorithm that then goes ahead and groups it up? It's a lot of math. And remember I talked about that data preparation being a lot of the effort? It's taking the data that we have and preparing it so that I can use math on it, so that I can go ahead and segment my groups. So that's kind of what's going on behind the scenes. Now, once I have done that, and I've segmented people into groups, and by the way, so I've segmented people into groups, I'm probably going to segment movies into groups. And if you think about movies and shows and how I can segment them, there's a variety of things. What's the genre? What's the what's the rating of the movie? Who's in it? How long does it run? All kinds of information exists that I have about these movies. And the very same types of algorithms that I use to segment my people, I'm going to use to segment movies and make segments of movies. All right. Now here's a really clever thing that they do. As I have subscribers on Netflix, and if you're all use some of these services, how many times do they ask you, hey, what did you think about this show? Hey, what did you think about this movie? You are helping that service do a better job of recommending and making better decisions. Because the next thing that they do is they take you as an individual or you as a group, and then they ask you about those movies. So now they have all this information and they merge these two things together. How did these people in this group rate a particular movie? All right? And so they use some kind of math to do it. It could be as simple as the 1 through 5 rating. 5 is good, 1 is bad. So I'm just going to add up those scores from all the people that rated the movie. And the higher the number, the more people liked it. And since these movies are already grouped or segmented, I probably can start guessing that people that like a particular movie will probably like movies that are similar to it. So think about all that, that interconnectivity there. All right, now, here comes a subscriber, and as a subscriber logs in and provides information, I know a little bit about that person, not a lot quite yet, but a little bit, and I can start trying to match up what is this person. What group does this person most resemble? What group would I put them in if I were going to put them in a group? Knowing the characteristics of that person, I can try to fit them in a group. Knowing what group they fit in, I have a sense of what they may be like. And since I know that they belong to a particular group, I know the kinds of movies that particular group likes. So I can now start making recommendations to this person about shows. So they watch a particular show, I can see that they are similar to one of the groups that I've segmented. I can start recommending other shows that that particular group likes. And as you stick around and you start watching more shows, I can start learning more about you and the shows that you watch. So my recommendation engine now has more data to go ahead and figure out what shows you might like. And that's kind of an oversimplified way of kind of like how this thing works. It's very clever. It's kind of neat. I know we pretty much just sit back and take our recommendations in and go ahead and watch some new shows. There's a lot of cool math and science going on under the covers to make that all work. All right, so American Airlines and price optimization. American Airlines was actually one of the first airlines to start taking advantage of analytics to price tickets in a certain way. And so what they basically did is they noticed and they realized, and this was a while back, that they could segment bookings, and doing that segmentation allowed them to give different prices to different customers. Now, why on earth would they do that? Well, I think by now everyone kind of knows why they do that. And if anyone's been on Orbitz or American Airlines or Travelocity, one of the things that you've noticed is as you go looking for tickets, the prices don't always stay the same. And part of what's going on there is there's some very elaborate data mining and predictive analytics going on that's helping determine what the price should be. Now, why do we try to determine what the price should be? As it turns out, I can go ahead and fill my planes to capacity and offer, from an American point of view, for example, and offer the best price where I get the most revenue and profit out of the deal, and at the same time ensure that all my seats are getting filled. So I don't want a plane to take off from Chicago and go to Atlanta with half the seats empty. It's much better for me to find and to put bodies in those seats, and I can do that by making sure that I'm pricing those seats appropriately. Two people sitting on a plane in the same row aren't necessarily paying the same price. And everyone's aware of that, but this is done through price optimization using prescriptive analytics. All right, now I want to get to my favorite of all of these stories of how this stuff all works, and that's Google's self-driving car project. I call this the ultimate in prescriptive. If you remember what I said about prescriptive, there's really two layers, the ones where I give options to the human to make a decision, and then there's the one that says, I'm not going to give options to the humans to make a decision, I'm just going to act upon that. The Google self-driving car project is the marriage of all the cool technology that's going on right now. It incorporates big data, the Internet of Things, machine learning, prescriptive analytics. It's all bundled in there to make this thing work. So I'm basically operationalizing predictive data to the ultimate level where I'm driving a car. Well, I'm not driving a car. The car is driving a car. So there is so much cool math going on in this problem, and I'm going to apologize to any data scientists out there. I'm not a data scientist, but I certainly can appreciate what's going on out there. There's a little video that I want to show you here that talks a bit about how this process works, and then we'll go and explore and talk about it a little bit. So let me see if I can get that video actually showing up here. Give me a second. I'm going to maximize this.
I'm Priscilla, one of the test drivers on the Google self-driving car project. Our team is responsible for keeping the cars and other people safe while on the road, and for providing feedback on how they perform in the real world. A big part of our job is to go out into the world and uncover all the potential scenarios that a car might encounter. Then we help the engineers teach the car how to best navigate each one. Here are some examples of situations that we regularly encounter on the streets of Mountain View, California. We've taught the vehicle to recognize and navigate through construction zones. Our sensors spot the orange signs and cones early to alert the car of the lane blockage ahead, and we can change lanes safely. You'll also notice the vehicle typically moves to keep a safe distance away from large obstacles, like this truck stopped on the side of the road. Now we're approaching a railroad crossing, which requires special care. Notice the red fence and railroad sign that appears to the computer as we approach the intersection. This means that we'll wait until the tracks are clear of other vehicles before proceeding. Our cars treat cyclists as a special category of moving object. Watch in this example, when the cyclist holds up his arm, our software detects the hand signal and predicts his movement into our lane. The car knows to continue yielding to the cyclist passing by, even when he changes his mind, multiple times. We still have more work to do, but it's fun to see how many situations we can now handle smoothly and naturally. See you on the road.
All right, by the way, if that was a little bit choppy for you, in the presentation there's a link to this video that you can watch it yourself. Very, very cool stuff. Let's talk about that a little bit here. And, oops, let me get my presentation back up. Let me go back one slide. All right. Now, besides this is really cool stuff, there's a little bit of all the cool technologies that we work with in analytics going on here today. There's big data and the Internet of Things, and there's predictive analytics, and there's prescriptive analytics. It's all playing in here. It's amazing how much stuff is going on, and the adventure that Google is going on with this particular project. Let's start by talking about how does the car know that something that's next to it is a truck or is a railroad crossing or is a cyclist waving his hand? One might think that, oh, I know, it's processing these images, and so it's recognizing what's going on here. The reality is that the machine is not memorizing every permutation of every image of every cyclist, but it's recognizing the digitized version of that visual. It's basically the binary representation of that visual, and finding patterns in those movements, pattern in those shapes, and it's learning about what these things are. So that's done through a variety of techniques. There's unsupervised learning and supervised learning. We're going to talk about that a little bit. But the idea is that all this data that's streaming in is being processed at real time, and it's using historical data that the system has captured to get smarter about what it's doing, and ultimately leads to a car that can drive itself. It's the pinnacle of technology and analytics. Very cool stuff that's going on here. So I want to step back and talk about the analytics architecture. Remember that data warehouse pattern that we talked about at the beginning, that the sources, the data warehouse, and the presentation layer, the ETL process. You're going to find that pattern showing up in today's what I'll call intricate analytics architecture. And so you'll see that some of the columns here are pretty much the same. So I do have my data sources. I have mechanisms for collecting this data. I do persist the information, and then I present that information. I can present that information by doing my traditional descriptive and predictive analytics, or I can present that information by taking it to that next level, the prescriptive analytics, as we saw in the 3 examples here. So I want to chat a little bit about what's going on in here. Our data sources today vary greatly. Everyone's already heard the presentations of how much data we're generating and how much data is out there, and it's growing leaps and bounds every year. This is certainly true, and that's because of our transactional systems for our organizations. It's because of social media. It's because the Internet of Things and all these devices and systems and applications are generating data. So if we're going to take advantage of these things, we have to collect this data, and that's even harder than it ever was before. We have our traditional ETL processes for our structured data and data that we want to persist into some database. There's also streaming data that we want to deal with and work with in real time. I can't go ahead and take, for example, sensor data and store it in a database and then analyze it and then act upon it when that sensor data is controlling my jet engines, for example. I can't wait to persist that and analyze that. I want to make sure that that sensor data is being acted upon as efficiently as possible in real time to make sure that my plane is flying effectively. So it's more challenging than ever because I do have the regular ETL process. I have streams of data that I have to contend with, and traditional ETL tools don't work for that. And then I have to persist that data. And sure, it's easy to persist my traditional structured data, but that's not the world that I live in today. I have data that is unstructured. I have data that is huge. I have data that changes rapidly, and even the structure changes rapidly. And I need different ways of dealing with that. And so there's a variety of technologies that help me to do that. Not that I'm promoting any of these, but I just wanted to give names to some of these things. So I have Hadoop, I have MongoDB, I have Spark, I have my traditional RDBMS systems. So now that I talked about all the stuff that kind of lives in the world of traditional data warehousing, I want to talk a little bit about this machine learning, predictive analytics, and prescriptive analytics. So the idea is that I want to create some models that takes this data, figures something out, and then pushes the data back out somewhere where I can take action upon it. And so we know about data scientists that are out there, and so what is the role of a data scientist in all this? Well, the data scientist is the person that's going to go ahead and create these algorithms that do the predictions and the segmenting and all that fun stuff for us. And to make sure that those systems are running in a healthy way, in a way that's actually still valid. And once that's done, I operationalize this algorithm and I make it part of the workflow of my data. Whether that's a real-time stream or whether that's working on the persisted data, I incorporate that into the mix here, so that not only am I showing the historical data, but I'm also showing that that predicted or forecasted data. And once I've done that, I can start taking advantage of it by either passively using my traditional BI tools, or more proactively incorporating it as part of my workflow, as we saw in the Google self-driving car, in the pricing for American Airlines, or in the recommendations from Netflix. So key thing that I wanted to point out, data scientist, data science, there is a very important term that makes part of that label, and that's science. And the word science is actually abused, and I want you to realize that science means something very specific. It basically means try things to figure out a problem. Some of them are going to work, some of them are not going to work. You might not ever get them to work. But the idea is that science is about figuring out different approaches to solving a problem until you do or don't. And that's what the role really of a data scientist is, and that's where where some of the art and experience comes into play, so that they can come up with these models. Once the model's created, I'm all good. I can go ahead and operationalize that, and I'm off to the races. And the models can be tweaked. The approaches can be made better, just like Netflix had that contest to make a better recommendation engine. It doesn't necessarily end with one model that you create. As your data and life changes and the world changes, that model that worked 5 years ago, that model that worked a month ago may not be working this month. And depending on the volatility of the information, all that has to be taken into account. All right, so what is machine learning? Everyone is familiar with the way that we typically deal with data today. We are accustomed to writing programs or developing algorithms for computers that work with data. It does the work on data. Machine learning is kind of interesting. It kind of flips it around. In machine learning, I'm not using the human to develop these algorithms to work on the data, but I'm using data to develop the algorithms, and I'm letting computers do that for me. It's really turning this on its head, and that's a powerful thing, because remember, the computer is fast and tireless, and the computer can work on this stuff and try many iterations of trying to get it right in the time that it would take me a lifetime. All right, so as a quick little summary, so what is machine learning? Let's remember that computers aren't smarter, they just work faster and tirelessly. And so what we want to do with machine learning is find and exploit patterns in the data that I have. So instead of the humans writing code, humans are providing the data, and then the algorithms that I'm using, and there's quite a few, this is where the data science comes in, algorithms that I use to look for those patterns, and those patterns based on examples. There are two types of machine learning that we talk about. There's supervised learning and unsupervised learning, and there's a difference between those, real quick. Supervised learning is basically learning to predict something based on past examples. What that means is I have a whole bunch of data, and I know what the answer is. And so when I have a whole bunch of data and I know what the answer is, I can take a chunk of that data, put it aside. I can take another chunk of that data and feed it into my algorithms so that the computer can learn and figure out, feed it into my, I'll use the word algorithm, so that the computer can figure out what is that pattern, what is the, how can I determine how these correct answers were arrived to. Once I have that algorithm worked out, I can then take my second chunk of data, that's my test data, and feed it into my algorithm and see if the model gets it right. And so that's the process of supervised learning. I have a whole bunch of data that I know what the answer or the outcome is, and then I can build a model based on that. In unsupervised learning, what I'm really doing is using the computer to learn how to organize something. I don't necessarily know what the answer is, but there's patterns and stuff in there, and the more data I have, the better. Because what I can do is I can let the algorithm look at the data and figure out what patterns exist. I can have it cluster things and find similarity in the data. That's unsupervised learning. And once again, my apologies to data scientists for my oversimplification of this concept, but that's really what I'm trying to do, is introduce the concept of what these things are. And as I said earlier, I'm not a data scientist. All right, so what's the secret sauce? How does this all work? It's math, is really what it comes down to. And it's typically linear algebra is what makes this stuff all work. So if you took that linear algebra class in college and you kind of said, what the heck am I ever going to do with this, and forgot about it, don't you wish you remembered now, because that's where it's at. So if you want to be a data scientist, you better go back and refresh your skills in linear algebra. All right, so the next question that we have to ask is, can machine learning work for me? And it depends. And there's a couple things that you can think about when you're wondering, can I use machine learning to do something here? And basically, if the problem that you're trying to solve, if automated prediction is core to that problem, then likely yes. Do you have lots of historical data that's available to you? Then the answer is probably yes. And so these two criteria, if you fall under there, there's a potential that machine learning can work for you. What about the no answer, obviously? So if prediction plays a minor role in the problem that you're trying to solve, well, there's no point in going through the effort and the cost of using machine learning, because you don't need it. If past or historical data is not available to you, you're not going to have a very high level of success because there's no data to either find a pattern in or no data to train an algorithm in. If your business process has many, many complex rules, it's probably not going to work with machine learning. And if there's no predictable pattern that's evident, it's probably not going to work with machine learning. So it doesn't fix everything, but it's a very powerful tool in many of the situations that we find ourselves in. All right, and so I have here a thing where I'm going to ask questions, or I'm going to let you ask questions. So here's what's going to happen, because we are 3 minutes before the end time of the presentation. Any questions that are in our chat box, we will go ahead and respond to. Anyone who attended the meeting, we will send out the answers to all those. If you come up with a question after the presentation, well, you have my email address over here, and you can send it out there, and I will try to get back to you as well. What's next and how we can potentially help you. And if we think about all these analytics types problem, whether it's descriptive, predictive, or prescriptive, I want you to ask yourself, is your organization, are you taking advantage of all the analytics that you might have access to, or analytics that you could possibly use? Are you providing good analytics to folks within your organization so that they can make good decisions? Is your data warehouse that you have today meeting your needs? Is your BI tools that you're using today meeting your needs? Are you having trouble with adoption? Any of these types of things that's keeping you from moving forward in that maturing of your analytics life, that's something that we can certainly help you with, and I would certainly love to help you with. So if you have any questions or find yourself in need of these things, you can either send an email out to info@dunsolutions.com, or you can reach out directly to me, Jose@dunsolutions.com. That'll work as well. All right, folks, it's just about 12 o'clock Central Time here. That's the end of my hour. I do want to thank everyone for attending this presentation. It was fun for me to prepare for it and present to you some of the neat ways that prescriptive analytics are being used. And keep an eye out. We will be having more presentations on these topics in analytics. Probably focusing maybe a little bit on big data later on, and maybe some more machine learning, all kinds of neat things that we're going to talk about. I certainly appreciate your time. Everyone have a happy holiday and a prosperous new year. Thanks so much.